Okay, we're going to continue with our factoring. We've done some other types of factoring. This one has to do with quadratic form, although the first one here is just a regular factoring problem. So if I were going to factor this, I would just do it a traditional way. I don't even need the x method on this one. So I've got x and x. I've got 1 and 12, 2 and 6, 3 and 4. This is 3 and 4. This is negative, so there'll be opposite signs, but this one's positive, so the bigger number is going to be positive, and that would be it, and I'm done. Okay, so what I'm going to do, though, is I'm going to extend this type to a problem that said this: if I have x to the fourth plus x squared minus 12, it has the same coefficients as the one above it, but the actual problem looks a little different, but it's handled the same way. So I would say f of x is equal, and so when I get ready to factor it, instead of x and x, it will be x squared and x squared. It's still 3 and 4, and then I have minus and plus. And so when I look at this, neither of these will factor. In fact, this one is not even a real root. This would have an I in it if I were looking for roots. And this one would be the square root of 3, plus or minus. So this is what we're doing, is graphing or factoring in quadratic form. Okay, so here's another one. And you can see that I'm going to start it off the same way. X to the fourth is just x squared times x squared. A is 1, so I'm good. And then the factors of 10 that add to 7 are 2 and 5, and they're both negative. And that's it. If you were looking for roots, like if I wanted to find the roots for this, I would set x squared minus 2 equal to 0, and I would set x squared minus 5 equal to 0, and solve. So I would have x squared equals 2. Square root would be x equals plus or minus the square root of 2. X squared equals 5. X would equal plus or minus the square root of 5. And you'll notice here that I started off with x to the fourth, and I have 4 roots. So I carried it a little further, but basically you're still factoring and solving. Here's a slightly different situation. It doesn't look like it's x to the fourth, but what you'll notice about each of these terms is that they all have an x. So one thing that you'll want to do before you factor this is actually factor out a common factor. So I'm going to factor out an x, and I get 3x to the fourth minus 2x squared minus 8. This may be one of those situations where you would want to use the x method. So I would do a times c, which is negative 24. b is negative 2. I need the factors of 24 that subtract to get 2. So that's going to be 6 and 4. The top number is negative, but the bottom also is negative. So that means that negative 6 times 4 equals negative 24. And negative 6 plus 4 is negative 2. The final step on the x method, if you'll recall, is to divide both of these by 3, which is a. So this one reduces to negative 2, and then it will factor lovely, that's not a word, x minus 2 and 3x plus 4. Of course, you want to check it, 3x, squared. So I've done something wrong. No, I just forgot to put the 2 here. So I've got 3x to the fourth plus 4 minus 6 is negative 2 minus 8, and so that works. So this would be the factor, and I didn't leave room for my f of x equals, but I would have 5 roots by the time I solved this. Okay? Here's a fun one. First of all, you definitely want to factor out any common factors. So when I start this, they all have an m, so I'll take it out, and they all have at least an x. So if I take an xm, that's going to be x to the sixth, plus 2x to the third, minus 15. Boom. So this is not to the fourth, this is to the third, which is kind of interesting. It's also a quadratic, a form of a quadratic. So I'm just going to carry this xm down. And what I want you to see, if I can write it somewhere over here, is that x to the sixth is the same thing as x to the third squared, right? So if we did one of those u substitution things, and we said that u is equal to x to the third, then this would be u squared plus 2u minus 15. Okay? Because, once again, u is x to the third, right? So look, think this through. This is going to be x to the third squared, which would be x to the sixth, and then 2x to the third. And then you can factor this u. So here I am carrying the xm down. I'm going to stay in red as long as I'm in u. And so I've got u and u. The factors of 15 that subtract to get 2 are 5 and 3. They'll be opposite signs, but the middle term is positive, so the larger number will be positive. Right? Almost done. Now I need to substitute back in for the u. So I have xm, u is x to the third, plus 5. This is x to the third minus 3, and you're done. So that's kind of hairy. Has a little bit of u substitution in it, but we've done that before. Okay, now I'd like to talk a little bit about domain and range. You've done this a lot in Algebra 1 and 2, and we're not going to stop doing it here. But I just wanted to remind you what it is and how it works. All right, so on here I have domain and range. If you'll notice on this drawing right here, it actually has it listed for you. The domain are all the possible x values of the function. This is not an infinite function. It stops here and stops here. So the domain goes from -5 to 4. The range is going to be the y values. The y values exist from -4 to 3. Okay, and you can do this, you can write it in interval notation. So for instance, the domain goes from -5 to 4, and the range goes from -4 to 3. So over here on this particular function, the domain and range is not going to be all reals for all of it. But you can see here that if this is an infinite function, and so it's going to go in the negative infinity direction and the positive infinity direction if it's allowed to go forever. So the domain of this one is going to be all reals. And we write that in interval notation, negative infinity to infinity. The range, however, is going to stop. It's going to go from negative infinity on the y-axis all the way up to 4. And so that's what that looks like. Actually, it includes 4, so I probably would put a bracket there. Circle, by the way, which is not a function, also has a domain and range. So the domain of this, which I can't actually see, but I think it goes 1, 2, 3, 4, 5, 6. I think it goes from -6 to 6. And the range, it's not a circle, it's an ellipse, isn't it? And it's a little smaller, but I can't tell what it is. I think it's -5 to 5. So those are the domain and range from a graph, and I think those are the easiest ones to do. Now, if it's a polynomial of any kind, its domain is going to be all reals, okay? Unless it's in a situation like this, where you have a polynomial over a polynomial. And in other words, you cannot divide by 0. So, for instance, this particular function right here, the domain for this one is going to be all reals, except where the denominator is equal to 0. And why the denominator but not the numerator? Well, because you cannot divide by 0. So x plus 4 equals 0, x is -4. So that means that the domain will be all reals except for -4. And if you're writing that in interval notation, you would go negative infinity to -4, not including, and then from -4 to infinity. That's an interval notation. Now, if you're going to do this problem right here, which it's kind of hard to see, but the denominator is x squared minus 100. Well, x squared minus 100 factors. So if I have f of x is 2x minus 1, I don't really care what the numerator is when I'm doing domain, I would have x plus 10, x minus 10, right? So this would be, the domain for this one would be all reals, but x cannot be -10 or +10. And you wouldn't write the plus, but that's what that is. And if you're writing that in interval notation, it's a little more challenging. So to negative 10, negative 10 to 10, and then from 10 to infinity. It's kind of long, but there you go. The second type that would limit the domain would be if you have a square root, because you cannot have a negative number under the square root. So to do these types of problems, you would take, like say on F, you would say 20 minus 4x has to be greater than or equal to 0, and solve for x. So I would have negative 4x is greater than or equal to negative 20. When you divide by the negative 4, it switches the sign, and so you have 5. So the solution set for that would be x is less than 5, or in other words, it would be from negative infinity to 5 included. Okay, same deal here. If you have 4x squared plus 50 has to be greater than or equal to 0, because it could be 0 under there. So I would have 4x squared is greater than or equal to negative 50. So x squared is greater than or equal to negative 50 over 4. And this is not real. So what's this saying to you? Well, what's this saying is, since these roots are not, it's not real, I'll write it, not real, that means there is nothing I can put in there for x that will make that negative under the radical. There's nothing I can put there. If I put a negative number, it squares it, makes it positive. If I put 0, it's still positive. If it's positive, it's still positive. So on this one, the domain is actually all reals. The third scenario is if you have both. If you cannot divide by 0 and you have a radical. So we know from the radical that underneath the radical, it has to be greater than or equal to 0 if all I have is the square root of x plus 1. But since this is in the denominator, it cannot equal 0. So instead of writing it this way, I would have x plus 1 is greater than 0, but not equal to. It can't be equal to. So the solution would be x is greater than negative 1. So that means I would start at negative 1, not including, and go to infinity. And that would be my answer. So that's the important thing to remember, is when the radical is in the denominator, it cannot equal 0. The whole thing cannot equal 0. So that's the only difference. Here are your 2 problems for homework. Please work these in your composition notebook, and I will be checking those when we come to class. See you in class.